Chale. So concave mirror for me is done. Concave mirror for me is done. In case the bell rings and a guy delivers a water bottle, I can come out, ask him to keep it here and to take this one. Right, thank you. Okay, so we start with convex mirror today. For my part, concave is done for me, unless you guys come up with any sort of doubt. Okay, so convex mirror, a recap of convex mirror so that you get into page what we had studied. So this is my principal axis, and this time my mirror is going to be in this manner. This is my mirror. Okay, this is my mirror. So the rough surface would be this one. This is my rough surface, the pole of the mirror. Now the focus will be on this side, and this is the center of curvature. So we always say that a convex mirror has a virtual focus. Convex mirror's focus was obtained by divergent rays. A beam of parallel rays which were incident on this face got diverged. So they appear to diverge out from the focus. So this focus is always virtual. And while you do problems with convex mirror, the focal length will always be positive because you are measuring this side. Is this clear to everyone? Have you got this idea? The focal length in case of a concave mirror used to be negative while we used to do problems. Here the focal length will be positive because the focus is on this side, right? And the focus is a virtual focus. You remember, parallel beam of rays will come and they will diverge out. Then the question is, from where do they diverge out? They all diverge out from the focus. No, they appear to diverge out from the focus. Yeah, so the focus is a point which is the meeting point of rays which have been extrapolated, not actually. Okay? Any questions so far on convex mirror? Now it's cleared. So we will see the image formation rules. Image. Same as but there will be a slight bit of understanding issue. Image formation rules. Right? What you do is that I'll just relax for 1 minute. Make this diagram, 4 of these diagrams you make. 4 such diagrams you make. Same diagram, 4 places. I was thinking today was mathematics. I'm really getting old now. Okay, I'll do it in 3. Once you're done, let me know. Ready? All done? Anurag, Shreya, ready? Shall we start? Okay, chalo. So we go by the same logic. A ray of light which is parallel to the principal axis will always pass through the focus. So this is my first rule. A ray of light which is parallel to the principal axis will pass through the focus, but in this case you cannot pass through the focus. So this ray of light, now just understand, this ray of light will actually diverge out. आपका या मेरा? नहीं, आप ही का. Okay, so write down. A ray parallel to the principal axis appears to diverge out from the focus. In concave mirror, we used to say a ray parallel to the principal axis passes through the focus. Here, a ray parallel to the principal axis appears to diverge out from the focus.
So the arrow direction will change.
This arrow direction will be changed. Sorry. Yeah. A ray of light parallel to the principal axis. Look. Don't write like that. First look, then you'll understand. English you know better than me. A ray of light parallel to the principal axis, appears to diverge out. The ray diverges out. But from where? Appears to diverge out from the focus. Done? Ready for the next one? The next one I will do in the same diagram, okay? But I'll show with a different color.
So should we do it in the next diagram?
Yeah, you should do it in 4 diagrams. Y'all are hardworking, mehnati balak. A ray of light that passes through the center of curvature, that will always remain undeflected. So here we will say a ray of light directed to the center of curvature. A ray of light directed to the center of curvature. Directed to the so I have to make it in reverse manner. 1 minute. A ray of light directed at the center of curvature reflects back undeviated. Means if it has gone in this direction, it comes back in this direction. A ray of light directed to the center of curvature is reflected back in the same direction, in the same path rather. A ray of light directed to the center of curvature is reflected back in the same path. Whereas in case of concave, what we used to say, anything through the center of curvature remains undeflected, because there you could touch the center of curvature. The only difference is here you cannot touch all these people. Convex will make all virtual.
I think we have already done image formation. Object like
No. These we have not done. These rules we have not done.
Sir,
Yes, sir.
can you repeat what we have designed for the previous diagram?
Which one? The yellow ray or the green one? Which one you want? Green one. Okay, green one I will not repeat. You look at me first. Ray of light parallel to principal axis gets diverted, right? Gets diverted. So we have to be specific. A ray of light parallel to principal axis appears to diverge out from the focus, or appears to get diverted out from the focus. Why yellow wala line? Yellow wala line you write on your own. A ray of light directed to the center of curvature. Directed to the center of curvature. You can't reach the center of curvature, Shreya. So you can only direct it. Comes back. Comes reflected back in the same path. So if you, she got frozen. If you actually take a concave mirror, which we have studied so far, there you could touch the center of curvature. So our English used to be a ray of light through the center of curvature gets reflected back in the same path. Here we will say a ray of light directed to the center of curvature gets reflected in the same path. Agreed? Next one. So our next one would be, again I'll go with green itself. So next one is, this was parallel to principal axis. Now our next ray will be directed to the focus. Our next one will be directed to the focus. Okay, a ray of light. So in concave, what did you study? A ray of light through the focus becomes parallel to principal axis. So here we will say a ray of light which is directed to the focus is reflected back parallel to the principal axis. A ray of light directed to the focus is reflected back parallel to the principal axis. Understood?
Yes.
A fourth one remains same. At pole, what happens? At pole, we will always, now since you are a little bit, at pole, we will think it like it behaves like a plane mirror. So this becomes like your tangent to the pole, right? And you will have a normal out here. This is the normal. So the angle of incidence at pole will always be equal to the angle of reflection. So take a ray and direct it at the pole, and with the same angle the ray will be reflected back. So we say that the angle of incidence at the pole is same as the angle of reflection, theta theta. Because at pole the spherical mirror is almost behaving like a plane mirror, not plane mirror, plane dosa, plane mirror, plane. It's a plane mirror. Fourth one beta is plane. You know laws of reflection, grade 8. Angle of incidence is equal to angle of reflection. So when you are at the pole, when you are hitting at the pole, so there is a tangent which is drawn to the pole, right? The tangent itself is now like a plane mirror, and this is the normal. This part is not there in your syllabus, but I'm just trying to explain you why this happens. Your syllabus will only say the angle of incidence is equal to the angle of reflection. Why that happens? Because at the pole we'll draw a tangent. A tangent is a line which touches a circular surface at one point, and then you make your normal. So this is your angle of incidence, this is your angle of reflection.
It makes the angle with the principal axis.
Yeah. The principal axis behaves as the normal. Yeah, that's why I drew that indigo line dotted, right? नहीं तो आपको यही बोलूंगा angle of incidence is equal to angle of reflection. For that reason itself I drew this normal. The normal coincides with the principal axis. Have we understood? Now when we were studying concave mirror, we studied object at infinity, object at focus, object between C and F, object beyond F, object at C, object between P and F. But this is a very cute mirror. This is a very cute mirror. Now, in order to understand its cuteness, let's first understand its use. Then the cuteness will be understood better. Convex mirrors are used in your cars, right? A bit of common sense will answer everything. All rear view mirrors are convex mirrors. So one question comes, no matter the person is just behind your car or very far behind your car. Just 1 minute, children. Thank you, Ji. Okay, thank you, Arish. Okay, so in your car's rear view mirror, no matter where you are standing behind the car, you will always see, if I am standing behind your car, you will always see me erect. Question does not arise. What about the magnification? Larger. देखो कितना अच्छा. No.
Smaller.
How can it be larger? What is the size of it? Do you see the whole buffalo in your mirror? No. You are again answering me wrong. Listen, take me. Do you see the whole buffalo in your mirror? Yes. Is that the size of a buffalo? Yeah.
Yeah.
Use your common sense. The car is supposed to give you a complete picture of what is happening in and around your car. We will see the whole truck. We will see the buffalo. We will see the person, everything. Are they the actual size of the objects? No. So two things we have understood. A convex mirror will always produce erect, virtual, and smaller than, not diminished, smaller than. Diminished means when you can't make out at all. And smaller than the object sizes. So the M factor will always be positive and will be less than 1. Is that understood? M factor positive and less than 1. Positive, why? Because everything is erect. Why less than 1? Everything that you see is smaller. Therefore, in this mirror, there will be two cases we will study. Object at infinity and object anywhere in front. If the object is at infinity, that we have already done. How did you define the focus of the convex mirror? Parallel beams came from the infinity and merged at the focus. So if the object is at infinity, the image will be formed at the focus and the image will be erect, highly diminished, just like a point. So that case we don't study. We will study only one case. Object anywhere in front of the mirror. And that's the use of a convex mirror. Object anywhere in front of the mirror. Are we ready? So shall we make it? Chalo, let's make it. everyone understood this justification what I said? This mirror is a very cute mirror. This mirror will always produce smaller than size, erect and virtual. So let's take our criteria. This is the principal axis. Okay. So I'll just write here two cases we study. Object at lens cart. Lens cart means infinity. Object at infinity, then image is at focus. And it will be. Come again, Shreya?
Is this image formation?
Image formation, yeah. Image formation by convex lens. Sorry, convex mirror. Convex mirror is very cute. Only one case. Image is highly diminished, virtual, and it will also be erect. This is a case which we don't draw, but this is what we are going to draw. Image anywhere in front of mirror. So you will always get virtual, erect, smaller than object. And we don't say the position is before F, so we just say behind the mirror. Behind the mirror. And that is what exactly your car rear view mirror tries to do. So let me make my mirror out here. Okay.
Second case, right?
One minute, one by one. Share first your question, then the other question. Yeah, tell me.
So we got the diagram in second case.
Yeah, the second case. The first case diagram you have drawn. You remember how you define the principal focus of a convex mirror? Very first class. The ray of light which will be coming parallel, they will all diverge out. So you bring them back, they intersect at a point. That point was called focus. That is exactly this diagram. This you have done at the very first or second class itself, when we are defining the principal focus of a concave and convex lens, convex mirror. Yeah, it will come. If you want, I'll just do it like this. See, it will come parallel to principal axis like this. All of them will get diverged out. So where do they get? They come here. So this was the case. You have done this. From here only you defined the first day that the principal focus was not principal focus. The focus of a convex mirror is a virtual focus. Yes, Anurag, you had to ask, or Ali, you were asking one question in between.
I was doing the same question.
Okay, right. So we go ahead now, and our images object is now anywhere in front of the mirror, right? Anywhere. So let this be our object. Our object. And let this be the focus. Let this be not 2F. Here we call it as C. C. Fine. So we go by our same funda. A ray of light parallel to the principal axis was what? Appears to diverge out from the focus. So you have to now diverge it out from the focus. Let's diverge it out. Appears to diverge out. How many rays do you need to form an image? Minimum 2. You can take more than 2 also. So second one, your wish, we can take at C. You can take this one also. So we will say a ray which is directed to the focus. Okay. So let's say a ray which is directed to the focus. Will this go to the focus? I think so. I think so. No, this will not help us. So we'll take the one for C. It's directed to C. Okay. We can take this one also. A ray which is directed to focus. A ray which is directed to focus. Nahi ware acha. It is not as stylish as I was thinking it to be. You don't like. Diagram is not okay. Still not okay. Still थोड़ा सा उठा हुआ है. Okay. Now what will happen to this? This will get out parallel. So we will not do it this way. A ray of light which is just give me 1 minute, huh? Which is directed to the focus will get reflected parallelly. Yeah, better. So you can extrapolate this line itself. And you get your image.
Okay, extrapolate towards the focus.
No, I'm extrapolating the reflected ray. That was a rule. This should be dotted because this is virtual. So if the object was AB, the image is A dash B dash. And A dash B dash will always be smaller. But that's all. Nothing more to do out here. Okay. One ray which was parallel to the principal axis will always appear to pass through the focus, right? So the ray will go out in this manner, went out in this manner. And another ray which was directed to the focus, this was directed to the focus, it went out in this manner. Now concentrate on this one and this one. Aren't they divergent rays? Yes. Will they ever meet in near future? No. So I pull them back. So there is one signage issue, huh, children? Sorry. I don't know. This should be in this manner. This is a reflect. So this is a reflected ray. This is a reflected ray. They're not going to meet. So we pull them back. The parallel ray has been pulled back. This ray has been pulled back. They intersect here. So that's the virtual image. Okay? Clear? Okay. If this is clear, can I go ahead and just tell you a little bit about what care? Okay, sure. Finish it up. No issues. Some care that you have to take on sign convention while you are solving problems related to convex mirror. Convex mirror will be a rare mirror. Problems will come, but it is not that it doesn't come. It does come. How it will come, I'll tell you. Nowadays, CBSE will give you competency-based question of 4 marks. In that 4 marks, there will be a numerical. That numerical will be, the whole problem will be of concave mirror, but they will give you an or, one question or with a convex mirror. वैसे आ जाता है. Now, whether you want to do you can't say that no, they did not give. But if there are 5 problems which come on concave, only 1 problem comes on convex. Because convex, we can't play that much. This is fixed. Whereas in concave, you can be confused. More criteria can be created. Shall I go ahead? Okay. Some sign conventions that you need to take care. Sign convention. Need not memorize anything. Once your funda is clear, then everything is clear. Let's look at some sign convention. This is my principal axis. Sorry. And this is my convex mirror. Okay. What all are the parameters we play with? F, U, V, HO, HI. We play with these parameters. Yes or no? Now let's go by F. The F is always on this side, beta. The F is always on this side, and you would be measuring in this way. This is your F. So your F is no matter positive, right? Object is always kept here, and the object distance will always be measured this side. So your U will always be negative, right? The object height, object is always taken erect, so this will always be positive, right? The image formed is always an erect image, so the image will always be positive, and the image will be formed behind the mirror, so the image distance will always be positive. However, don't goof up. Magnification still continues to be minus V upon U and HI upon HO, because the magnification formula is for a mirror. It is not specific for concave or convex. अभी देखो subject पे grip आ रहा है कि नहीं? Yes sir, grip comes very nice when we come to your class. But between 1 week we enjoy like anything. We go for swimming, video games, and whatnot. Yes or no? है ना? War of God, duty of call. Duty of call, AGT6 and all. AGT6, bhai sahab. Spider-Man 2, FIFA 24.
Magnification will be positive.
Magnification always positive. Ultimately, whatever way you solve this, you will get the magnification positive because your image is also upright, your object is also upright. So from here, let us ask some questions on a rapid fire mode to ourselves. Magnification negative means what? Magnification negative means image is always inverted because object was always erect. Okay, magnification having a value more than 1 means enlarged. Magnification having a value less than 1 means always smaller than object. If we look at this brother of ours whose name is convex mirror, then their values will be always m plus less than 1 because they are always producing erect smaller than the object. So the magnification values for all problems related to convex should be m plus less than 1. And let's go to our concave. Concave can have m minus. Minus is very common. M minus equal to 1 at C. M minus less than 1 when object was placed beyond C. M minus greater than 1 when object was placed between C and F. Then M plus you will get greater than 1. M plus greater than 1. In that case, lipstick dentist, object is placed between F and P. And if you get M infinity negative, that means object is placed at focus. And M infinity absolutely 0, object is at infinity. More kya chahiye? So easy, so nice, so beautiful, just looking like a wow. There was one reel, right? Just to come. So beautiful, so elegant, just looking like a wow. So this is a wow. Agreed? So let's talk about some uses of these mirrors, okay? Some uses of these mirrors. Obviously, you have understood that convex mirrors are used for what? Rear view lenses, and convex views for cars, because the main idea is they give you a wide angle view. What do you mean by a wide angle view? Now say, suppose I had a plane mirror. If you have a plane mirror, why is a plane mirror not used in a car? Obviously, I have not fallen in love with the buffalo that I should see an equal image of the buffalo. I love your eyes when you're behind me. Aisa thodi hai, right? A plane mirror will create an image which is equal to the object size. So you won't see the whole buffalo. He will say, I'm just seeing an ash colored object. That is one portion of skin of the buffalo. Agreed? Plus, the wide angle view, if you see the view on this one, okay, if you see the view on this view is a wide angle view. Then you can also have the wide angle view, it will give you. That's why we use convex mirror. Okay, concave mirrors. Where do we use concave mirrors? When you go to grade 12, you will learn about two types of telescope. One is a refracting telescope, one is a reflecting. Okay, let's talk about refracting telescope. Refracting telescope, ractings, have got lenses. Now lenses you can make very big, but they become very cumbersome because you can only hold them in their rims. Because lens you can't cover any other portion. Look at my specs. The lens is held only in the rim. Now this is a small spectacle lens. Imagine this lens to be 10 meters in diameter. So you will be holding only on the rim. How bulky and cumbersome it becomes. So nowadays all the hobby telescopes and telescopes that you buy, those telescopes will always have a concave mirror. Because you know, in concave mirror, if Jupiter is at infinity, Jupiter's image can be formed. Where? At the focus, which will be smaller. Telescope never magnifies. Telescope brings tele-objects to your scope. Microscope magnifies. Some child wrote that telescope magnifies. Arey, you idiot, is the size of Jupiter this much? Jupiter is very, very big. So telescope brings tele-objects to your scope. So the concave mirror in a telescope will do what? The concave mirror will be actually creating one small image. And then we will use a convex lens and we will magnify that image. That is how a reflecting telescope. Acha, now question arises, sir, don't you have holding problems with the mirror? A mirror's backside can be used as a support. Mirror does not have any problem if you hold the mirror on backside. Don't you see when heroines do this and then one spot boy will be holding the whole mirror? You can hold it. Yes or no? But in lens you can't do that. You get it? So another use of convex lenses, using them as security mirrors. Then using them as in blind spots. Convex mirrors. Convex mirrors are used in security mirrors for shoplifting. In shops they used to put it because it gives you a wide angle view. Or and parking lots, they help you for, if you have a convex mirror out here, like in all basements, if somebody is coming from this side and this fellow is coming from this side, both can be viewed. But in India, I have seen no one looks at this. Ultimately, they will come here, exchange few hot words with each other, but no one looks at this one. And there are some more intelligent people who drive in the basement without their headlights on. You should always drive in basements with your headlamps on, because in a group of 50 cars, if one car just moves, the human eye cannot make it out. When there are 80 elephants and one elephant is tagging its tail, wagging its tail, can you make out? No. So you should always have your headlights on. The headlight will sparkle here and it will give him an alert. So we use them for blind spots, safety mirrors, as well as we also use them for security mirrors used in shops. Nowadays shops use all CC cam. Nobody uses all this technique. And used in rear view mirrors. Whereas a concave mirror, what all did we see? They are used by dentists. They are used for beauty compact mirrors, shaving mirrors, used in telescopes, and also used in many optical instruments like cameras, binoculars. They also use these mirrors. Satellites, everywhere. Wherever you need to converge rays, our job will be to use a concave mirror. Wherever we need to diverge rays, we will be. Even, do you know, have you ever visited an ENT doctor? An ENT doctor, like a Roman god, will be wearing one headband. And in front of his headband, there will be one DVD-like disc. That is actually a concave mirror. And then he will have your ear right in front of him and a lamp which will focus. And that will produce a big sharp beam with which he will actually see the what?
Yeah.
The pinna, the outer ear, the middle ear, and the inner ear. Consist of 3 bones. What are those? The hammer, the anvil, and the stirrup. After that, there is cochlea, the jalebi-like thing, where there is a lot of juice. And then auditory nerves. Bhul gaye? That's all about reflection. And with this, we come to the conclusion of reflection. There's nothing more. Okay, 3 mirrors are given to you, and they have not said what is which mirror. And you are to identify without touching the 3 mirrors that which is what mirror. Anyone who have visited a science museum, whether it's in Goa or Bangalore, you'll see all these fun things. Okay, a lot of mirrors will be there in science museum. So 3 mirrors, how to distinguish? If you stand and you see yourself just the way you are, you're standing in front of a Plane mirror. If you see yourself stout and little bit shorter, you're standing in front of a convex mirror. And if you see yourself as ulta, that is, then you are standing in front of a concave mirror. Such questions also come. With this, we conclude our chapter on reflection of light. Shall we do some numericals now on convex? एक आध numericals कर लेते हैं. आ जाइए. We'll do one numerical on convex. You will do. I will not do. You have to just take care of that sign. Ready? Okay. So let's take one problem. Ding, 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 ding. Okay, first problem. Object height 5 centimeters. So you can just write HO 5 centimeters. Object height HO 5 centimeters. And it says it's placed in front of a convex mirror. Convex mirror. And it is placed in front. Placed in front. And that in front is 10 centimeters in front from a convex mirror, and the radius of curvature of this mirror, in fact, they're telling you, giving you a hint about what? The focal length, not focus, focal length, right? You need to tell us nature, position, and size. Nature, position, and size of the image. Nature, position, and size. Chalo, do it. Who does it first gets nothing. Who does it last may get something. Yeah, Vakul, the way you are researching on it, a question is between the last 7 days. Did you see this chapter? If not, then it is all Greek and Latin. You can wait till someone solves it. In Glendale, what is being taught, Ray? Then what are you doing? School is also teaching this. I am also teaching this. Then what is causing you problem from not studying this? Did this man, this tall, dark, and not so handsome man, start numericals in your class? Last class? After that, he gave you a love letter on numericals, which you have been making an aeroplane out of it. You want me to do a PTM? If you want me to do a PTM, I can do a PTM. Pouring water on sand only empties the water. Sand does not get wet. Have you ever poured water on sand? Water will get finished out. Sand never gets wet. Counseling, Vakul, is analogous to that.
Yes.
PX means position, my dear. That's a little bit scientific way of writing position. PX. Mirror is I, so it will be addition. Addition has got I. आया तकबीर कर आराम से. फॉर्मूला लगा 1/f इक्वल टू 1/v प्लस 1/u. u तो नेगेटिव होगा, f पॉजिटिव होगा. Otra darling, happening or not? Great. Yesterday I saw Atreya going to bus stand. I crossed Ananya going to bus stand. You guys don't see me because I was driving my car. So Atreya, while crossing P Tower, 3 times he has adjusted his hair. And it is not seen by me. Me and my daughter were there in car. So she says, how many of your students will cross? I said, there is one coming. So 3 times he has adjusted his hair by the time he's crossed P Tower. Ananya, I have crossed maybe 10 inches. She has not seen. Right at the turn, in front of P. You're getting inside the P arena and I'm taking a right turn with my car. Are it done or not? We don't have the whole day. Anurag, why is there silence, sir? Have you solved or not?
Yeah, almost.
What is almost? I don't know what is almost. हो गया? जरा बताइए. नटूरे क्या है? नटूरे will be virtual. Then it will be erect. Position, how much? V's value.
6 centimeter.
How much? 6 centimeter. Size, HI. HI is 3, HO is 5. That means magnification factor is how much? 3 by 5, which is equal to 0.6 positive. बस हो गया. और करना ही क्या है इसमें? All of you got these figures? If you have not, I'll help you. Don't worry. Don't hesitate. Anurag, Mila. Sure though? You are not being vocal. Generally, when you get an answer, you are always vocal. Today you are a little bit silent. So दबाओ मत बेटा. कोई बात नहीं. मैं करके दिखा सकता हूँ. Image size we'll explain once again. Shall we do this problem? Okay, let's do this problem. Let's do this problem, okay? So I will go by my formula. 1 upon f is equal to 1 upon v plus 1 upon u. What all data are given to you? Radius of curvature is given as 30. So 1 upon f I am taking as 1 by 15. Anyone has any doubt on this? This being a convex mirror, my focal length will be positive, correct? Okay. Image distance, I don't know. I don't know. Okay. Object distance is how much, Beto? This is placed at 10 centimeters. 10 centimeters. So object distance will be plus 1 upon negative 10. Is this clear now? Right? So my 1 upon v now will be equal to 1 upon 15 plus a 1 upon 10. Is that fine? 15 and 10, what should be the LSM? 30 should be the LSM. If 30 is the LSM, then this becomes 2 and this becomes 3, which is a 5 by 30, which is a 1 upon 6. That means V is equal to 6 and we are getting positive, which is correct because the image should be formed behind the mirror. So V as 6 you have got. Very good. Now we look at ma. Ma is how much? Negative V upon U. Now negative. What is the value of V? 6. What is the value of U? Negative 10. Because U is negative always. Minus and minus cancel each other, which means we are getting positive for magnification, means we are correct. And we should get a value less than 1. We are getting how much? 6 by 10. 2 3s are 6, 2 5s are 10. Since the denominator is bigger, this is a proper fraction whose value is less than 1. So we are correct. Understood? 3.6.
After that you will find.
So little bit starting yarn on refraction. Ready? So we will stop the video recording here so that two